Good morning, geometry students. Welcome to class this morning on this Tuesday morning. Hope you guys are doing well. Hope you're ready to learn some math this morning. And hope you guys have a good rest of the week. Jasa, hope you guys do well at the state tournament coming up this Thursday and Friday and I guess Saturday also. Grab your notebooks while I'm talking here, your books, your pens, your pencils, everything else that you need. Let's have a great class period today. You guys know me well enough by now to know that I expect you to pause the video if I go too fast, and I don't really try to do some fantastic things. I'm just pretty plain, and we just get things going. So here we go. No quiz or test this week. I have yet to hear back from Mr. Harmon, but I'm sure he'll let me know. I'm asking him when is a good day to test or quiz. I don't think Friday's the best day for this class with the computer lab and stuff like that. Turn in your homework at this time, would you please? Now, some of you turned it in yesterday, but if you did not turn it in yesterday, it is due today, so please turn your homework in. Jasa, don't forget test by tomorrow. That's really important, okay? Mr. Harmon does have the test. I emailed him the the makeup copy. And then retakes by Friday. One student emailed me last night, and I emailed him back. I've not checked my email yet. When I say last night, I'm making this video actually Tuesday morning, right now at about 6:45 in the morning. So someone did contact me last night, and that's good. But all retakes must be done by Friday. It does no good to take that test if you don't study. So please study. And then lastly, there'll be no homework tonight. I'm gonna give you a lot of notes today. We're gonna go pretty slow and really, really hope that you're getting this stuff. If you happen to finish the video early, please don't goof off. Find something to do. Work on some makeup work or study for your test. I know, JC, you've got a makeup test, and others of you might want to do a retake. So study for your test. But there will not be homework tonight. That means tomorrow when you come into class, we're doing homework only on Wednesday. And I want you to work, watch the video, and learn, because this is some very important stuff. If you get lost now, you will be lost for the rest of the year. So please, please, please pay attention, work hard, and call me or email me if you have any questions. All right? Let's go ahead and get started. Wow. Today's the day. Today's the day I've been warning you guys about. We are going to start looking at two-column proofs. Now, let me tell you, two-column proofs are a type of problem. So it's not a type of math that we're going to learn, but they're types of problems, just like in Algebra 2, when the teacher told you, hey, we're going to learn how to factor today. It was a type of problem. And factoring is fundamental to Algebra 2. Two-column proofs are also fundamental for geometry. So we're going to start those today. So instead of being scared, be really intense and really focused and listen well. We are also going to start looking at different ways to prove when triangles are congruent. Remember, students, about 2 weeks ago we learned how to prove when two lines are parallel. We learned 5 ways, alternate interior angles, congruent, etc., etc., etc. We learned 4, 5, or 6 ways, I forget, to prove. I think it was 6 ways to prove that lines are parallel. Well, we're going to learn 5 ways in this chapter to prove that triangles are congruent. 5 ways, okay? Today, we're going to learn 2 ways to prove that triangles are congruent, okay? 2 ways. So here we go. While I'm talking, just go ahead and write this heading down. We're looking at 2 ways to prove that triangles are congruent. 2 ways to prove that triangles are congruent. The lesson number is 5-2. And the date today, if you like to keep track of that, and I encourage you to do that, the date today is the 22nd, 10/22. Okay? 2 ways to prove that triangles are congruent. Now here's the first way. Please write this down. We call this the side, side, side postulate, or SSS postulate. And it's obvious why. Look at this. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then we know for sure the 2 triangles are congruent. So if we have 3 sides of one triangle congruent to 3 sides of another, then we can state beyond the shadow of a doubt that these 2 triangles are congruent. Now you might say, well, Mr. Earhart, that's pretty obvious. Well, hold on. I mean, don't write this down, just watch. I could give you a triangle that's 60, 60, 60 on the angles, and then give you a triangle like this that's also 60, 60, 60. And just look at those two triangles. Are they congruent? Question mark? No way, not at all. Remember what we learned yesterday. Please don't forget what you learned yesterday. The only way a figure is congruent is if all of the angles are congruent and all of the sides are also congruent. And so just because you have certain parts of one triangle, like 3 angles, congruent to 3 angles in another triangle, that doesn't mean the 2 triangles are congruent. So really learn these 5 ways to prove that triangles are congruent. Really learn them well, okay? So here we go. If 3 sides of one triangle are congruent to 3 sides of another, the 2 triangles are congruent. Please write this picture in your notes, would you please? Go ahead and put triangle ABC is congruent, or not, I'm sorry, go ahead and put triangle ABC and triangle DEF. Copy this in your notes, and then go ahead and mark the congruent sides. Now notice we have one side here, and if you need to pause the video, feel free to do that. We have one side here, congruent to one side over here. I have one side here, congruent to one side here, and I have one side here, congruent to one side here. So I have all 3 sides of one triangle congruent to all 3 sides of another triangle. Now when that happens, I can state then for sure that these 2 triangles are congruent. There we go. So that's what this postulate does for you. If you know 3 sides of one triangle are congruent to 3 sides of another, then we know the 2 triangles are congruent. Now can I challenge you to do something, please? How about writing a congruence statement? Remember yesterday we matched up congruent angles with congruent angles, and we can't do that here. We can't do that. It's going to be really difficult. So let's go ahead and write a congruent statement, and let's see if we can't figure this out. So we have triangle ABC. So I'm going to go ahead and put triangle ABC. By the way, if you put BAC, CBA, CAB, ACB, ABC, it doesn't matter, okay? I just randomly chose to put ABC. Now, let me show you something, please. Watch this very carefully. If I chose to put AB right here, okay? See my first 2 letters? AB. See that side right here? It has 1 slash through it. Then what I had better put over here had better be EF. All right, do you see that? So I'm going to go ahead and put EF. All right. Now, and actually, to be honest with you, I'm always trying to improve my teaching. Let's do this real quick. I think when I know there's a better way, I'm going to go with a better way, okay? So let's do this. I want us to write a congruent statement, and let's try this. Do you see how here I have 1 slash on this line here and 3 slashes here? Do you see that? And they form that angle right there. Do you see that? Well, let's come over here, and here's my 1 slash line, and here's my 3 slash line, and they form an angle right here. So that tells you right there that A corresponds with E. All right, so that helps me see which angles are congruent. It'd be easier to do it this way. So I'm going to mark A congruent to E. Okay, now look, here's a 1 slash side and a 2 slash side. Do you see that? And it forms this angle right here. Well, here's a 1 slash side and a 2 slash side, and it forms that angle there. So that tells me B and F go together. Okay, so B and F go together. So I'm going to put 2 here and 2 here. And then obviously the last angle that's left has to be 3. I think that'd be the easiest way to write a congruent statement. Now I'm ready to go and do it. So triangle ABC is congruent to triangle, let's see, what angle goes with angle A? E does. What angle goes with angle B? F does. And what angle goes with angle C? D does. There we go. All right. So it's good practice to do that. All right. Now I've got a question for you. Copy this problem in your notes, please. Remember, it's going to be a lot of notes today. It's going to be a very long video, but there'll be no homework tonight, okay? All right, copy this problem in your notes. Can we state that these 2 triangles are congruent? Triangle number 1 right here and triangle number 2 right here. Can we state that these 2 triangles are congruent? Well, let's think about this for a second. Please watch this carefully, okay? First of all, I'm going to go ahead and tell you, remember, if you need to pause the video, feel free to do that. That's your job to know when you need to do that. I'm going to go ahead and tell you now the answer is yes. Now let me show you how I can state that these two triangles are congruent. Do you see how the triangle over here on the left, notice how I have a side here with a slash and a side over here with a slash. So those two sides are congruent. And notice how GI has two slashes and HJ has two slashes. Do y'all see that okay? Now, watch this. This is really interesting. Do you see how they share a side, HI? Let me go ahead and show it to you this way. Of course, you might already see it, which is okay. If I can get this thing to work here. There we go. Alright, so I'm going to grab this triangle here and pull it down and turn it just a little. There. And now we'll grab this triangle here and pull it down and turn it just a little. There we go. Okay, do you see how I pull those two triangles down? And notice this is HI right here, and this is HI right here. Are they not congruent sides? Sure they are. They're the same side right here, are they not? We call that two triangles. You don't need to know this, but we call this two triangles sharing a side. So these two triangles share a side. So because they share a side, we know that this side here is congruent to this side here. Do you see that? So I know this. I know that I have three sides over here in this triangle congruent to three sides over here in this triangle. So yes, based on my postulate right here, my side, side, side postulate, I can definitely state that these two triangles are congruent because I have three sides of one triangle congruent to three sides of another triangle. Now let's see if we can't very quickly write the congruent statement. See how one side here, or one slash here and two slash here forms this angle. So here's one slash here and two slash here forms this angle. So I know for sure that G and J go together. So I'm going to mark G congruent to J like this. And notice how this is my three slash line right here. Notice how I have one slash with three slashes, and I have one slash with three slashes. So this angle here goes with this angle here. So I'm going to go ahead and put 2 marks here and 2 marks here. And then of course the last angle gets 3 and 3. So if I were to write a triangle congruent statement, I would say triangle GHI, and by the way, you could put these three letters here in any order that you want, it doesn't matter. Triangle GHI is congruent to triangle, let's see, G goes with J, so J goes first. H goes with I, so I would go second. And then my last angle, of course, would be H. Triangle JIH. There we go. I hope you're getting this. If not, you need to contact me, set up some help time or something, okay? It's very important that you see this. Now, I did tell you that we're going to learn 2 different ways today to prove that triangles are congruent. So here's the second way. Go ahead and copy this into your notes. The postulate reads as follows. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. Then the 2 triangles are congruent. I just had a thought, and I don't have many of those. If we don't finish the video in class today, you need to finish it at home tonight. Okay, and that's just how it is, okay? So if we do not finish the video in class, which I think we will, you need to finish it tonight at home. So let me read this one more time. It's called the side angle side postulate, or SAS. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. Let me give you a picture of this, okay? Here it is. Now please draw this in your notes, write this in your notes, and listen carefully. Notice how I have a side here with 8. I'm going to put 1 slash mark, and a side over here with 8. Those 2 sides are congruent. Notice how I have a side here with a measurement of 7 And notice how I have a side here with a measurement of 7. Those two sides are congruent. Now, do you notice how these two congruent sides form an angle right here? Do you see that? Do you see how these two congruent sides right here form an angle? Do you see that? That's what we mean when we say an included angle. It has to be the angle formed by these two congruent sides. If you don't have that, then you do not have the SAS situation. You do not have it. For example, let me show you something. Please watch this carefully, okay? Please watch this very carefully. If this 30 degrees right here wasn't there, let's pretend it was down here, and we marked this 30, and let's say this 30 was down here. You could not say, oh, you might say, Mr. Gerhart, I got two sides at an angle over here and two sides at an angle over here, so I've got SAS. No, you don't, because this angle right here, if you're going to use the SAS postulate or reason to prove to me that these two triangles are congruent, then this angle has to be right here in between the two sides that are congruent. If that angle is not there, now listen to me carefully, I'm not saying that if the angle's down here that these two triangles are not congruent. Maybe they are, maybe they're not. But what I am saying is you cannot use the SAS postulate unless this angle is right here between these two sides that were congruent. And I hope that makes sense, okay? I hope I'm not confusing you more, but you need to know this, okay? So copy this in your notes, and this is a picture or a snapshot of what this postulate is saying. If two sides and the included angle is congruent to two sides and the included angle, then guess what? We know for sure, beyond the shadow of a doubt, that these two triangles are congruent, okay? Now, since we know that, let's go ahead and write a congruence statement, shall we? Let's go ahead and do this. Well, there's only one. Now that we know that these two triangles are congruent, then we know that all their parts are congruent. So I'm going to go ahead and put 3 tick marks here and 3 slashes over here. Okay? Now, do you see this side of 8 right here? Do you see that? Here it is, right here. Do you see it over here? Same thing, same side. Well, that means this angle here has to correspond to this angle here. All right? So now I know that K and O are congruent. So 1 mark here, 1 mark here. I guess I could put 2 marks here at my 30 and 2 marks here at my 30, and my other angle has 3. So now that I've marked all of my parts congruent, writing a triangle congruent statement should be pretty simple. I can say triangle KLM, and you could have written these 3 letters in any order that you want. It doesn't matter. Triangle KLM is congruent to, let's see, K comes first, and O goes with K. L comes second, and N goes with L. And then the last angle, M, right here goes with P. So there we go. There's a congruent statement. Okay? I hope this is making sense. This is called the side angle side postulate. Now let me warn you, what we're going to do now for the rest of the class period is we're going to go ahead and work 2 problems. And the 2 problems we're going to work are called 2-column proofs. So we're now going to look at 2 proofs. Okay? So sit tight. Make sure you're all caught up here. Take some notes. And then if you don't finish the video, you must finish it tonight at home. Okay? All right. Go ahead and copy this into your notes, please. I know this looks like Greek to you, and that's fine, but go ahead and copy this in your notes, and I'll explain what to do in just a second. Now, you know me well enough by now to know I don't wait for you, so pause the video if you need to, but you need to copy this in your notes. Now, the first thing you do when I ask you to write a 2-column proof, the first thing you do is you pick up your given, and you put it onto the diagram. Let me show you what I mean. They tell us that JL is congruent to NL. Do you see that? So I'm going to mark JL with 1 slash and NL with 1 slash because that's what my given said. Notice also they gave us L as the midpoint. That means L is in the middle of KM. Now here's KM right here. Here's KM right there. And L is in the middle. Now if L is right in the middle, then we know for sure that this segment here is congruent to this segment here. All right? Now that's our given. Here's what we're trying to prove. All right, we're trying to prove that JKL, we'll call it triangle 1, is congruent over here to triangle NML, which is triangle number 2. That's what we're trying to prove here, okay? Now here's what you do when you're doing a two-column proof. Please take some really good notes. I did not forget to do this ahead of time. I just felt like it was best to do it right in front of you, okay? So here we go. First of all, you write the word statements, okay? And I think I'm going to go ahead and increase the size just a little bit in case you guys are watching it on the big screen. Okay, there we go. So go ahead and write the word statement, and then write the word reasons, and that's going to go right over here. Now next, what you do is you put a line going down. It's a dividing line and a line going across. Do you see what you're doing? What you're going to do is you're going to list out statements and give me a reason. All right? So you're going to explain to me how you know for sure that these two triangles are congruent. Do you understand what we're trying to do? You're going to put a statement here, like something's congruent to something, and then over here you're going to tell me why. And your reasons over here have to be stuff that we've learned in the past. You can't just make something up like, well, it's Tuesday and I feel like it, okay? It's got to be a theorem, a postulate, a corollary, a definition, something we've learned in the past that you know to be true, all right? So here's what you always do. Let's repeat ourselves. Step 1, you always take your given right here and you put it onto your picture. That's the first thing you do. Then secondly, you go ahead and set up your two-column proof. And then here's the first thing you always write, okay? I think I'm going to go ahead and use the pen now for this part. It'll be a little faster. What you always do is you write your given. So go ahead and do that, please. Go ahead and get your pen, and you put a number 1. It's your first statement, and you put JL is congruent to NL. Then you can put a semicolon if you want. It doesn't really matter. And then you can abbreviate L. In fact, I wouldn't even put is. I would just put L midpoint of KM. That's good enough. Now, what is your reason that you did that? Well, you put given because obviously it was given to you. So you're allowed just to say given. Now, in your very last step down here, okay, I'm not sure what number it'll be, so I'm just going to put question mark. I'm not sure if it'll be step number 2, 3, 4, 5, or 6, but the very last thing that you have down here, students, should be what you're proving. So the very last step down here should say this: triangle JKL is congruent to triangle NML. And the reason I'm going to give whatever number it is, I'm not sure what number it's going to be. We'll put the number in later. Whatever the reason is, I don't know yet, so I'm going to leave that blank, okay? So let's go over this again. I'm trying to go really slow and make this make sense. You pick up your given, you put it on the diagram. Next, you set up your two-column proof, and the first thing you always write here is your given. So you write your given, and what is the reason that you wrote this? Well, it's obvious. It was given to you, so you put given. Then I always teach my students, jump down to the very end, leave a bunch of space here. You have no idea how much space you're going to need, so leave a bunch of space. And remember, your final goal is to put this proof part right here with a final reason. All right. Now let's use some common sense. Are we not trying to prove that two triangles are congruent? Yes, we are. What's the two ways we've learned to do that? Well, we learned today side, 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 and we also learned today side, angle, side. Do you see that okay? Those are the two ways that we've learned to prove that triangles are congruent. So to be honest with you, I'm going to go ahead and use a little common sense. In my very last step down here, come on, think about this. When I state that this triangle here is congruent to this triangle here, I'm either going to use this reason here or this reason here. It has to be one of those. That's the only two reasons I've learned is to state that triangles are congruent, right? So it has to be one of those two reasons. All right. Now let's go ahead and walk through this. I already have stated right here. I'm going to circle it for you. I'm going to circle it in red. I already stated right here that JL is congruent to NL, right? I already stated that. Now what I would like to state next in my proof is that KL is congruent to LM. And you say, Mr. Arrowhead, it's on your diagram. Yeah, it is. But did I state it over here in my statements? No, I did not. I don't see it anywhere. So I've got to state that. So I'm going to go ahead and state that KL is congruent to LM. Now, Mr. Earhart, why are you doing that? Because remember, I'm either trying to prove that all three sides are congruent, or that I have a side angle side scenario. Because once I'm able to prove that, I can then state that my two triangles are congruent. So I'm just trying to get some things written down that I know. And I do know for sure that KL is congruent to LM. Now you've got to give a reason. How do you know that? Well, I know that because L is the midpoint, right? Isn't that, it says right here. So how would you write that over here? Well, you would say this. You would say, remember, you got to use definitions, postulates, corollaries, and theorems, stuff like that. Your reason is definition of what? Definition of midpoint. Remember earlier this year we learned the definition of a midpoint, and the definition of a midpoint is it's a point on a segment that divides the segment up into two congruent segments. So I know that KL is congruent to LM. How do I know that? Because definition of a midpoint. The given told me that L was the midpoint. So I know L is the midpoint. I know that. But now I know that KL is congruent to LM based on the definition of a midpoint. Let me grab something to drink here. Hold on one second. Now let's continue on. Wouldn't it be great, students? Come on, watch. This will make sense. Watch this. Wouldn't it be great if I could somehow state that this angle here is congruent to this angle here? Why would that be great, Mr. Earhart? Because I would have side angle side. Look, I would have one side here congruent to one side over here. I would have one side in this triangle congruent to this side over here, and then notice that angle right here formed by the two congruent sides, this angle here is congruent to this angle here. So if I could just somehow state that this angle here is congruent to this angle here, I would be home free. Well, guess what? You can state that. We have learned a reason in the past to state that this angle here is congruent to this angle here. We have, yeah. Remember, it's called vertical angles. Think about that for a second. We learned that when two lines intersect, their vertical angles are always congruent. Okay? So these two angles here are congruent to each other, and these two angles here are congruent. So we can definitely state that these two angles are congruent. So what is the name of this angle right here? Well, it's angle JLK, right? Here's J, here's L, here's K. Please don't call it just angle L, because we don't know what angle you're talking about. Now, I'm going to tell you, I let my students do something. I'll tell you what, this is easier. I let my students write numbers on their diagrams, so if you want to do that, go ahead. We could call this angle 1, and we could call this angle 2. I have no problem with that. I love doing that. So actually, instead of using letters, we could just say this. We could say angle 1, isn't that easier? Angle 1 is congruent to angle 2. All right? Now, what's my reason? Well, my reason is because those two angles are what? Vertical angles. So you would just say vertical angles are always what? Congruent. There we go. Now, would you look at what you've stated over here? You stated that JL is congruent to NL. You stated that, let me get a different color here so it stands up a little bit, or stands out. You've stated that KL is congruent to LM. So you've stated this, you've stated this, you've stated this, you've stated this, and now look what you just stated. You just stated that angle 1 is congruent to angle 2. So students, do you not see what you have? You have side, angle, side in one triangle congruent to side, angle, side in another triangle. So now, it looks like it ends up being step 4. So now for step 4, we can state triangle JKL is congruent to triangle NML. And what's your reason? Well, your reason is side, angle, side, because that's what you put over here, didn't you? You have sides congruent to sides congruent to sides, angles congruent to angles. So you have side, angle, side. That's a 2-column proof. Now, this is a pretty easy one, to be honest with you. However, you're not supposed to find it easy, okay? I'm not saying that it's easy. for you at this point, but they do get more difficult than this. Also, on your tests and quizzes, I'm very reasonable with how many of these I give you, okay? The main thing a lot of you are struggling with, I'm going to be honest with you, I think you're being a little lazy, is you're not memorizing the fill-in-the-blank types of questions. And if you'll do that, you can actually struggle with these a little bit and still do well on your tests and quizzes. So I would not give you a ton of these on your tests or quizzes, okay? But you do need to see them, and you do need to have some because that's just part of geometry. Let's do one more and we're finally done. Again, if you don't finish this video, you need to finish it tonight for your homework. I don't wait for you to copy this down, so you might want to pause the video. It's up to you. Let me grab a quick drink of water while you're copying this last problem down. We are given that Q and S, angles Q and S are congruent, and that sides QT and TS are congruent. Prove that triangle QRT is congruent to triangle SRT. Okay? All right, here we go. The first thing you do, like I've taught you, is you take your given and you put it over here on the picture. So angle Q is congruent to angle S. QT, put a slash here, is congruent to TS. Put a slash here. All right? So that pretty much took care of that. Actually, I should have first, there we go. That's a little better. Put this, this, and this, and this. Now, this is what we're trying to prove. So we picked up our given, we put it over here on the picture, and next, like I told you guys, next we set up our two-column proof. So I'm going to go ahead and put the word statements, and then I'm going to put the word reasons. So we have statements here, reasons here, and now we're ready to roll, okay? Now, what I've taught you to do, if you remember from the last problem, is you pick up your given and you write that first. So number one, angle Q is congruent to angle S. Put a comma or a semicolon, whatever you choose. Doesn't really matter. And then QT is congruent to TS. All right? And of course, my reason is my given. Now, if you don't like my idea of jumping all the way down here and putting what you're proving, that's fine. You don't have to. For me, I like to get a picture of what I'm doing. So I jump down here and I put triangle QRT is congruent to triangle SRT. Now what that does for me is it gives me a picture of what my final goal is so I don't forget. And of course my reason over here, I'm going to put a blank. I don't know. Well, actually I do know. Remember, students, I know my reason is going to be either what? Do you remember? We've learned two ways to prove that triangles are congruent. So my last reason here is going to be side, 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 or side, angle, side, okay? But we'll get to that in the end. All right, so look what we have so far, students. Learn to use some good common sense, okay, students? Please learn to use common sense. Are you ready for this? I have an angle here congruent to an angle here. Do you see that? Sure you do. And I've got a side here congruent to a side here. So I'm really pretty close to proving this, I think. Now, would you do me a favor for a second? I wonder if I can get rid of this line here. Okay, good, I can. Could I show you something real quick? Would you see if this makes sense? I'm going to pull this line down here and get rid of it for a second. Now, we learned something last week. It was on your test, actually. When two angles in a triangle are congruent, see this angle here and this angle here, their opposite sides are congruent. Do you remember that? Does that make sense? Think about it. When two angles in a triangle are congruent, their opposite sides are congruent. So somewhere in my proof, I am going to be able to state that this side here is congruent to this side here. And what would my reason be? Well, my reason would be two angles in a triangle are congruent, so their opposite sides are congruent. It's not always easy to see sometimes when there's a line right down the middle of the triangle, and that's why I move that line. In fact, I'm going to go ahead and state that now. So let's go ahead and state, now watch carefully, Q, R, I'm going to put two slashes here, is congruent to R, S. Put two slashes here. Okay, now what's my reason for that? 2. Look how I abbreviate like crazy over here. 2 angles in a triangle are congruent. That's good enough for me. I don't make you write really long explanations. Just make sure I know what you're saying. If 2 angles in a triangle are congruent, then their opposite sides are congruent. Look how close I am. Hey, students, look. I know that one side is congruent to one side of a triangle. I know this side is congruent to this side right here. You know what? I think I'm done. I've got side angle side again. Look, this is so easy. I've got an angle. I have a side congruent to a side congruent to a side, and then the 2 congruent sides form this angle here, and your 2 congruent sides form this angle here, and this angle is congruent to this angle because that was given to me. I have side angle side of one triangle congruent to the side angle side of another triangle. So students, this is a 3-step proof. I can now state that this triangle here is congruent to this triangle here, and my reason would be, let's go ahead and put this reason number 3, my reason would be side angle side. And here it is. Look, here's my angle. I stated that my angles were congruent. I stated that these 2 sides were congruent, and I stated that these 2 sides were congruent, so I can definitely state that these 2 triangles are congruent. That's what a 2-column proof does. It takes you from your given, you start there, and work your way until you have proven what you're attempting to prove. Okay, students, I hope you understand this. If you don't, guess what? You're normal. This takes a lot of time and a lot of practice. And if you never become very good at this, remember my tests and quizzes are set up in such a way that you'll have these, but you can still do really well even if you struggle with proofs, if you'll just learn the rest of the math. And by the way, on any problem that I give you on a test or a quiz, a proof like this, think about it. Do I not give partial credit? Sure I do. So you could always at least write the given. That's one point. That's one step there you'll get, and you can write other steps in. You might get partial credit. And so these proofs are not easy, but they will not kill you as long as you know the rest of your math and do really, really well. Okay. When you come in tomorrow, have your books, have your notebook, pen and paper, and we're going to do homework tomorrow in class. Okay. JASA on Thursday and Friday. We're doing a lesson on Thursday, a long lesson, no homework, and then on Friday, homework the entire class period. So you're only missing 1 day of notes and 1 homework assignment, even though you're missing 2 days. So I kind of did that also to help you a little bit. So make sure over the weekend you email me and get those videos, or look them up yourself or whatever, because you really, really don't want to get behind. Okay. Hope you guys have a great day. Call me or email me if you have any questions.